Okay, so the unit circle. Yay. Now, so everything we've been working on is going to make the unit circle so much easier. So the unit circle is something we basically just have to memorize. So it's a circle with a radius of 1 that is used a ton in trig. Okay, so let's look over at this circle over here. That horizontal length right there is x. The vertical length is y. And the hypotenuse is 1 because it's the radius. So the radius is 1. And the radius is the distance from the center to the edge of the circle. Okay, so let's find sine of this. So sine of that angle is opposite over hypotenuse, which is y over 1. So sine corresponds with y. Cosine is adjacent over hypotenuse. So that's x over 1. So cosine corresponds with x. Tangent is opposite over adjacent. So that is y over x. So sine corresponds with y. Cosine corresponds with x. Tangent corresponds with y over x. And then the coordinate p can be written as cosine of theta, sine of theta, which is really just x, y, which is the way you always write an ordered pair, x, y. So that's cosine of theta because cosine is x, sine of theta because sine is y. Okay, let's get into this madness. So we need to find radians and then sine of this, cosine, tangent, and the point. And these are all points. If we know these points right here, we're going to be golden on this whole circle. We just need to know these ones. Okay, so let's first start with our 30, 60, 90 triangle and our 45, 45, 90 triangle. These are going to help us so much on this unit circle. Okay, so radians, we need to convert to radians. So 0 degrees converts to 0 radians. 360 degrees is 2 pi radians. And remember, you can get that by multiplying by pi over 180. Now, we need to find the sine of 0 degrees. So 0 degrees is right here. Sine of that. So sine is my y value. The y value right there, maybe. What? The y value right there is 0 because it's still on the x-axis. Cosine corresponds with the x value. So the x value right there is 1. Tangent is y over x. So that's 0 over 1, which is 0. Now my point is cosine then sine, so that's 1, 0. Okay, that first one's pretty straightforward, pretty simple. Let's go to 30 degrees. So first we're going to convert to radians, so we're going to do 30 times pi over 180, which is pi sixth. Now we're going to find sine of 30 degrees. So sine is opposite over hypotenuse. So that's going to be x over 2x, which is 1/2. Cosine is adjacent over hypotenuse, so that's x squared to 3 over 2x, which is the square root of 3 over 2. Tangent is opposite over adjacent, so that's x over x squared to 3. Those x's cancel and get 1 over the square root of 3, and then we have to rationalize the denominator. So multiply by the square root of 3 over the square root of 3, and you end up with the square root of 3 over 3. Now that point is cosine sine, so that's the square root of 3 over 2, 1/2. Okay, let's look at 45 degrees now. So we're going to first convert that, so that's 45 times pi over 180. Reduce that down, and you get pi over 4. Now, sine of 45 degrees is x over x squared to 2. Those x's cancel. I'm left with 1 over the square root of 2. Multiply by the square root of 2 over the square root of 2, and I get the square root of 2 over 2. Cosine is adjacent over hypotenuse, so that's x over x squared to 2, which was the same as sine, So that's really the square root of 2 over 2. Tangent is opposite over adjacent, so that's x over x, which equals 1. So my point there is the square root of 2, comma, square roots of 2 over 2. Oh, I said that wrong. So square root of 2 over 2, comma, square root of 2 over 2. Okay, let's look at 60 degrees. So first, convert that to radians. That reduces to pi thirds. Now sine of that, so sine is opposite over hypotenuse. That's x squared to 3 over 2x, which is the square root of 3 over 2. Cosine is adjacent over hypotenuse, so that's x over 2x, which those x's cancel, and that's 1/2. Tangent is opposite over adjacent, so that's x squared to 3 over x, which is the square root of 3. So my point there is 1/2, comma, square root to 3 over 2. Okay, let's do 90 degrees. So we're done using our triangles now. Now we're just going to use this circle over here. So 90 degrees, first convert to radians, is pi over 2 radians. So sine is the y value. My y value right there is positive 1. Cosine is the x value. My x value right there is 0. Tangent is it's y over x. So that's 1 over 0. You can never divide by 0, so that's undefined. And then my point is 0, 1. Okay, 180. Change that to radians. That's pi radians. Why is this being slow? Pi radians. Now sine of that angle right there. So sine is the y value. So it's 0. Cosine is the x value. It's negative 1. Tangent is y over x. So that's 0 over negative 1, which is 0. My point right there is negative 1, 0. Now 270, convert that to degrees or to radians. That reduces to 3 pi over 2. Sine is the y value, so that's negative 1. Cosine is the x value, so it's 0. Tangent is y over x, so negative 1 over 0, which is undefined. And then that point right there is 0, comma, negative 1. Okay, these are important to mostly just understand where they come from. We're going to do a couple days on this in class also so that we can start getting the feel for this more because it's really important. Okay, last thing. So we need to figure out what trig functions are positive in which quadrant. So first, I want you to label this. It's going to go away in a second because I'm an idiot, but this is the first quadrant. This is the second quadrant. This is the third quadrant. That's the fourth quadrant. So think about, like, this is 0 to 90, first. 90 to 180, second. 180 to 270, third. 270 to 360, fourth. Okay? And then to see what trig functions are positive in which quadrant, you need to remember all students take calculus. Even if that's not true, just remember it. All students take calculus. Or you can make up your own thing. All students take calculus. So the first quadrant, all. Everything's positive in the first quadrant. Second quadrant, sine is positive. All students, so all, and then sine. Third quadrant, tangent. Take tangent. Fourth quadrant, calculus. Cosine. Okay, so all students take calculus. So that first quadrant, everything's positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. Fourth quadrant, cosine is positive. So all students take calculus. Okay? So let's look at this. If tangent is greater than 0, what quadrants could that terminal side lie in? Well, tangent is greater than 0 in the first quadrant and the third quadrant. So that's all, because it's negative in the second and the fourth. If secant is less than 0, which quadrant could that terminal side lie in? Well, secant goes with cosine. So wherever cosine is negative, secant is negative. So everything's positive in the first quadrant, which means cosine is positive, which means secant is positive. So that's not going to work. Sine is positive in the second quadrant, which means cosine is negative, which means secant is negative. So the second quadrant is one of them. And then let's look at the third quadrant. Tangent is the only thing positive there, which means cosine is negative, which means secant is negative. So that's the second or the third. Okay. If sine is greater than 0, what could those ones be? That's the first or the second. And then if cosine is less than 0 and cotangent is greater than 0. So first let's figure out where cosine is less than 0. Well, that's the second or third. We kind of just figured that out in B. Now, cotangent is greater than 0. Cotangent corresponds with tangent, it's the opposite of tangent, so we need to know where tangent is greater than 0. That's the first and the third quadrant. So the only ones they have in common are the third quadrant, so this must be the third quadrant. Okay? Remember to take the quiz. I will see you guys tomorrow.